it says that we're live. Great. So welcome again to another event. This is our 2 of 2 of our summer prelude, where we are showcasing our Google Summer of Code and Code for GovTech's DMP students. They're going to show their work. And I just want to thank you for watching. I want to thank the students for being here, the mentors who were able to make it here. We have a lot of projects. I wanted to give you a little bit of context, and in the spirit of Sugar Labs, my presentation is written in music blocks. By the way, can everyone hear me?
Yes.
Yes.
Awesome, thank you. Okay, I'm going to share my screen. Can you see my screen?
Yes.
Okay. Oh, I see. That needs to be over there. Okay. Okay, so we're doing a few, we're talking about a lot of different things here that are all under the umbrella of Sugar Labs. We've got Raspberry Pi, we have Flatpak, we have Sugarizer, we have games and activities, and Pippy. This is music blocks, which we talked about last week. And I'm going to just do a very brief overview of these projects created as a presentation within music blocks itself. Okay, so what is the Raspberry Pi? Well, it is one of these, I think they're called single board computers. Someone can probably correct me on that. But basically, it is a complete computer. You can see the HDMI port here. There's other ports like USB. There's all the essentials, the microchip, and I think the hard drive is like a SD, like a micro SD. It looks like we have some different generations here. But one of the projects this year is to do more work getting the Sugar desktop environment running on one of these. The other topic we're going to talk about a little bit is Flatpak, which is, in my words, a way of distributing and packaging software. So this is a promising way to get more Sugar activities into the hands of students and teachers. And I suspect this is a really old screenshot, but this was one of the screenshots, I think, on Wikipedia of Flatpak. Okay, so next we have Sugarizer. This is a screenshot. If you're familiar with like the Exo laptop, for example, or the Sugar desktop environment, it basically looks like that. This is the journal. This is what you would see at the start with the child at center and the journal underneath it, and all of the activities surrounding it. You can run it online or offline. And again, we've got a lot of different activities that work on Sugarizer, which we're going to talk about a little bit today. That project's led by Lionel Laské, and this is him leading a workshop with other educators on how to implement it in the classroom. So the activities, some of which we're going to talk about today, like the games, you can get on our Sugar activity library. Here's one example. Here's another example. There's kind of two different places or so where you can download and install those activities. And that's it from me. With no further ado, do we have Anurag, Singh, and Aayush Raj to present Raspberry Pi?
Yes, let me share my screen quickly.
Awesome.
Is my screen visible?
I can't see it, but can someone else confirm that they can see it? I have not been able to
Yes, it
see
is
it.
visible.
Awesome. Okay, go ahead.
Hi everyone. So today I'll be discussing several exciting topics that merge technology, education, and hands-on learning. First of all, we will start with an overview of Sugar Labs platform, move on to Raspberry Pi, explore some fascinating sensors, and then delve into integrating these technologies into educational activities. Further, we will see that how documentation and Raspberry Pi OS image will be created. So first of all, let's understand that what is Sugar. Sugar is an activity-focused open source learning platform that is designed for children. It seamlessly integrates collaboration, reflection, and discovery into its users. Its intuitive design allows children and teachers to use computer on their own terms. Students can reshape, reinvent, and reapply both software and content, creating a powerful and engaging learning activity. And you know what? Sugar embodies the principle of free software movement that is flawless. Now let's see another free and widely available chip, that is Raspberry Pi, a very cheap single board mother computer that is designed for education and hobbyist projects. It features an ARM-based processor which handles the operating system and runs application. It comes with different models and we can also vary amounts of RAM that is essential for running this application. The Raspberry Pi includes multiple interfaces like USB ports, GPIO pins, HDMI ports, and networking interfaces for connecting peripherals and enhancing functionalities. Next, let's see that what are the different digital sensors that I'll be using in this project to enhance the sugar activities. First of all, let's start with the motion sensor. This is a motion sensor that is used for the detection of changes in the infrared radiation, making it useful for security and interactive projects. It helps in detecting different small motions that are being done in the surrounding environment. Next is the sensors overview, including temperature and light sensor. It measures ambient light levels as well as temperature and humidity levels in the surrounding environment. One of the major important sensors that we can see is ultrasonic distance detector. It measures distance by emitting ultrasonic waves and calculating the time it takes for waves to bounce back. We can further see two more different peripherals. The one is accelerometer and other one is LED matrix display. The accelerometer, it measures the different angular velocity and acceleration. It is used for orientation sensing. And another one is LED matrix display. It is a grid of LEDs that can display text, numbers, and simple graphics as well. There are other key components of this project that are sensor integration, turtle measure, documentation, and creation of ARPA image. Also, we will see that how social media extra can be used for testing this. Now, what are the different components? First of all, we will explore turtle art activity. In this, we will try to integrate ultrasonic distance sensor, camera apparatus, and motion detect PIR. We can create blocks within Turtle that interfaces with PIR or motion detector. These blocks can include commands to monitor motion status, set detection parameters, and execute actions upon detection. Here is a simple snippet code that uses the measure detection using the GPIO library from RPy and gives us the distance that has been actually traversed by the given object. We can also utilize it to include in the PP activity. Since PP runs on Raspberry Pi OS, it can easily integrate with GPIO pins of the Raspberry. Users can write Python code in PP to interact with sensors, LED motors, and other hardware components. Here we are seeing a very simple traffic light controller which can be integrated using the PP activity. Here PP activity act as a sort of ID from which, using the export feature, the following can be exported directly into the Raspberry Pi OS image converter, and further it can be used to monitor the traffic control. We have also certain more activities like Measure. In Measure, we can use microphone and LED matrix display to have a plugin or extension that interfaces with the microphone. These functionalities capture audio signals from microphone and display waveforms or frequency spectra. Here we are also using the Python scripting. Other projects that can be included are physics, record activity, calculator activity, in which joystick LED display could be utilized. For example, in record activity, camera extension can be utilized. In physics activity, joystick, the X and Y axis movement can be utilized very beautifully to enhance the activity. Further, we move on to documentation and social. RPy docs that we are making that will cater us users interested in leveraging Sugar's interactive platform for educational purposes. This documentation will cover everything, that is, from installing RPy OS to configuring Sugar desktop environment. Additionally, it will provide detailed instruction on exploring Sugar activities, including launching the environment, navigating through the available activities, and utilizing them effectively. Also, there are primary mode interaction through social media, including Twitter, YouTube, and Hacker News. Next, we will see how a creation of RPy image will take place. There are majorly 5 steps in which I have divided this. The stage 0 include bootstrapping or creating a usable file system. Next, we can have a minimal system that creates an absolute minimal system which can be further utilized to create a light image or a very flashy image of the same thing. Next is desktop system, including X11 and LXD web browser and so on, corresponding to simple Raspberry Pi ordinary OS images. Further, we can convert that given light image into a full image. And this is all currently I have to present. Thank you for your time.
Awesome presentation. Yeah, I'm really excited about this. And yeah, if anyone has any questions, you can drop it into the chat, and we'll have a little bit of time where you can share. So next, I have SudoSu-bham. Can you just do a brief sound check? I know you came a little bit late. Can you unmute yourself? We can wait just a moment, but we might go on to somebody else and then come back. Again, SudoSu, can you try unmuting yourself? Okay, so let's go on to Samarth. Bagga?
Oh, yes, I'll just present.
Yeah.
Is my screen visible?
Can somebody
It's
else answer?
loading. It's loading, but it's not there yet.
Okay.
I just see.
It's completely.
So you should be able to just jump right back in.
Okay. Should I start?
Yeah, if someone can just confirm that they can see the screen though. Oh, I can see it, yeah. Go ahead.
Okay. So what I'm building for GSoC as my project is a Sugarizer 3D volume activity. So Sugarizer has a number of activities dealing on a number of things, which all focus on the sole purpose of teaching children and making them learn new things. So what I'm building is a new Sugarizer activity, which will be focused on exploring volume using dice. I am using Three.js and Canon.js to build this activity. The educational goal is to enhance the understanding of volume through interactive and engaging dice experiences. So what to expect is to firstly expect an engaging 3D environment with realistic physics. The features include adding or removing the dice, choosing a type of dice out of several options, including the various shapes, 3D shapes, popular shapes, which include tetrahedrons, cubes, and octahedrons. Then we can choose a board background. We can toss the dice with realistic physics, real life collisions. And then we can also include and add to the board dice which are numbered, which have numbers on their sides. And we can get the numbers which land on the top. So these are the types of volumes that I have included in my activity. And
I think the presentation is not moving forward.
okay. Just a second. Is it the same for everyone?
So what I do in this case is, can you go to the part where, because it's basically not sharing the part that's presenting. So why don't you just like click on number 2 and number 3 manually? Yeah, like that. Yeah, so just do that.
Okay. So it is visible now, right?
Yeah.
Okay. So these will be the type of dice, and so the execution is, like I said, using Three.js and Canon.js. Three.js is to render lifelike 3D dice and environments, and Canon.js is used to add the realistic movement and the collisions. Now I'll show you the progress I've made and give you a little presentation. I'll just stop sharing my screen for a minute. Is my screen visible?
Yes.
Okay. So this is the board, how it will look in the activity, and upon selecting the type of volume, you can add the volume to the board, just like that. And then you can select the remove button and remove the volumes. Then going here, you can select the type of volume that you want to add. Let's say you want to add a transparent volume where you want to explore the vertices and edges of the dice in a better way. Then you can add this, and you can use the zoom palette to zoom in to the dice. And you can move around and explore the vertices of the dice. And you can, lastly, you can even add a numbered dice like this. And you can get the total of the numbers which are landed on the top. And this activity is also multiplayer, which is a unique feature in all of Sugarizer's activities. So, and this is how I've created the activity. If you see the blue part, the blue vertices are the physics part of the activity. The they are the physics part of the world, and the red vertices are the 3D renders of the dice. Thus, I have created a physics body along with the 3D body and have merged the two to give a lifelike presentation like this. So that is all from my side. Thank you.
Very nice. Yeah. This looks really cool so far. Okay, so next, let's go on to our other Sugarizer activity with Utkarsh. Siddhpura. Can you say a few things? Yeah, we noticed that Utkarsh's sound is maybe a little hard to hear. Utkarsh, if you can just keep talking at, like a good volume, so that we can all hear you as clearly as possible.
Okay, is it better now?
Oh, that's much better. Yeah, keep going.
Okay, thank you. So let me present my screen. Is it visible?
I can't see the screen until after a delay, so if someone else... Oh, I see it now. Yeah, go ahead.
Okay, cool. So welcome everyone to my presentation on Sugarizer VueJS app. So before we dive into the details, let me quickly give an introduction to Sugarizer. So Sugarizer is an open source learning platform for children, inspired by Sugar from the OLPC project, which is one laptop per child. And the platform works for desktop, mobile, and browser. So yeah, here is the general outline for my presentation. Yep. So hey everyone, I'm Utkarsh Singh. I'm a third year undergraduate computer science student. This is my second year actually participating GSoC with Sugar Labs. Last year I've also worked with this amazing organization under Sugarizer itself. So last year I have created the chat activity, which allows you to collaborate on chats, creating chats, manipulating chats with peers, exporting charts, etc. And the word puzzle template, which enables teacher to quickly create custom word puzzles with any media like video, audio, or text. So student can practice vocabulary like in lecture itself. And also I have contributed much more things after GSoC. So let me discuss about the project objective. So my project this year is mainly focused on finalizing the implementation of Sugarizer core UI using the VueJS framework. So we need to migrate Sugarizer from Anurag.js, which we are currently using for our Sugarizer app, which works on most platforms like desktop, Android, web, browser, everywhere. But it is very deprecated. So it is not maintained. It is not maintained by anyone, and it is it is very hard to learn or find documentation and things about. So we are migrating to Vue.js, which is a fairly new framework and very popular framework for web apps. That's why we are migrating to Vue.js. We'll discuss what are the benefits for migration. So for the project, the key tasks are basically implementing the remaining screens in Vue. This project is continued from last year, so we have some screens that are still remaining to implement. Then I also have to integrate the tutorials, basically tutorial of the whole Sugarizer platform and like what activities does what and etc. Then I also have to port the electron functionality, which allows Sugarizer to run on a desktop, like as a desktop app on a GNU Linux, Mac or Windows anywhere. And then I also have to make it compatible with Android device, so you can also run it on your Android device. Basically, I have to make sure to that the Sugarizer works with the desktop, Android, and web with single code base. And I also have to implement remaining screens. So why migration? So migration first is a long-term sustainability. Like VueJS provides long-term support and stability as it is actively maintained. Then developers also find it easier to learn and work with VueJS. It also enhances the user experience, and being a popular framework, it also attracts more contributors because it is very easy to learn and it is popular. So it attracts contributors to Sugarizer. So let's discuss what are the features of the project. So first is neighborhood view. As I already discussed, the neighborhood view is still yet to implement. So I have to implement the neighborhood view, which allows you to interact with the peers. It displays all the users which are sharing the same server, and it helps you to collaborate on activities basically. And it also has this navigation functionality. It also has tutorial. So it basically enables the collaboration part of Sugarizer, which I have to implement. The second thing is I have to implement is journal. So the journal view help us to track the progress of the student, like what activities he or she has done, or like what assignment is pending, or what are the files that are being uploaded. So it keeps track of all that, and user can also filter entries and like do manipulate the whole journal according to their needs. So I have to implement all of those functionality, and I have to implement the UI part in Vue.js. Yeah, and the third one is cross-platform support. So the app should support various features for cross-platform development, like platform detection, like which platform we are running the Sugarizer on. Then we also have to conditionally render the UI based on that platform. Like it has to be responsive on different screen sizes. It might look different. So I have to implement that too. Then I also have to do local storage management, which is which is using platform specific APIs like local storage or Cordova storage for Android. So the Sugarizer app works seamlessly in offline mode. And I also have to create a functionality so user can easily transition between offline and online mode. Like user can enter the server URL and user can go online without much hassle. And so what are my future plans? So of course the first one is keep contributing to Sugarizer, and then I have to examine the current Sugarizer version, and I have to identify improvements during migration, because as we are doing migration, then why don't we improve it too while migrating? So I am looking for improvements while migrating. And I also have to develop a detailed plan for multi-platform support. Like how can I make it optimized so Sugarizer can work seamlessly on multiple platforms? And also it is easier for new developers. So I have to make it simple enough to so other user can easily contribute. Yeah, all right. Devin, you can take it from here. Thank you.
Great. Thank you so much for that detailed presentation. I think we're able to hear you, SudoSu. Can you say a few things?
Yeah, hi everyone.
I'm going to put on the noise suppression because it is quite noisy, and let's see if it works. Huh. I don't
Am
know.
I audible now?
Yeah, we can hear you. Go ahead.
Is my screen visible? Hello.
I can't see it yet, but just leave it there.
I see it.
Okay.
Okay,
go ahead.
So hi everyone, this is SudoSu-bham. My real name is Shubham, and I would be maintaining and porting 12 Sugar activities to Flatpak this summer. And my mentors are Martin, and Ibiam. So let's see what is Flatpak. Flatpak is a utility software mainly used for package management for Linux. Uh, Here we can share our application and users can download and use our application through Flatpak. It is advertised as offering a sandbox environment in which user can run application software isolating from the rest of the system. It doesn't interact with our system. It is isolated from that. Now, Flatpak works for a lot of different desktop applications. It doesn't care about how programs are made, which language we have used, either Python, Java, Linux, any language we can use and provide it on Flatpak. While Flatpak only runs on Linux, it can be used by applications that target other operating system as well. And application can be open source or proprietary. So mainly our Sugar applications are open source, and there are almost 27 applications available on Flatpak. So we have a number of applications available on Flatpak to reach a broader audience within the Linux community. So there are about 27 Flatpak activities, and I'm going to increase it by 12 more this summer. So there would be 12 more activities. What I would be doing this summer is I would be updating all the Sugar activities already published on FlatHub. So there are 27 activities which are already published, and I would be updating them. And almost 15 to 20 activities are already updated there. And another task is to add 12 more activities. So the list of those activities which are going to be there this summer are typing tutor, calculate, Falabrackman, cell game, make them fall, maths horror, flip stick, 52 activity. These are on the category of games as well as education. Like maths horror is educational activity, while uh, 52 activities a game. So that's all for today. Thank you.
Awesome. Thank you so much for your presentation. It looks like a lot of fun. I can't wait to see your progress. So that's it from you?
Yes.
Okay. Okay, so next we have Vaibhav Sangwan.
Hello everyone, am I audible?
Yes, SudoSu, can you mute yourself, please?
Oh, sorry.
There we go.
Okay, I'm gonna share my screen real quick. Can somebody confirm if my screen is visible or not?
Not yet. Now I see it.
Okay, great. So, hello everyone. My name is Vaibhav Sangwan, and over the course of this summer, I will be developing 8 math games of Sugar. I've been selected as a contributor for Code for Go Tech's dedicated mentorship program 2024, and I'm really grateful of this opportunity. Now, let's take a look at all the things that we are going to discuss today. First of all, I'm going to introduce myself. Then we will delve into what actually are Sugar activities, and then we will have a look at all the activities that I will be working upon. We will then have an individual slide for every activity describing what it does and what it consists of, and then in the end we will discuss the progress that I have made till now. Okay, so introduction. I'm a third-year engineering student at Bharati Vidyapeeth's College of Engineering located in New Delhi. I'm proficient in Python and have experience in game development using various libraries and game engines. I first started out with Scratch in my primary school, and then I moved on to a 2D engine named Stencil. After that, in my first year of college, I worked with Unity 3D, and now I'm working with Pygame with Sugar. So, what are Sugar activities? Sugar activities are learner applications, basically. Uh, these are basically the point where the actual learning happens. There are various sugar activities. There are around more than 300 activities in the sugar activity library. And some of these activities need no introduction or explanation, such as the maze activity that has a screenshot attached on the top left. All you have to do is move the player around to reach the destination. There are other activities that require some learning and exploration, such as turtle art. Moreover, there are games such as Memorize and Implode. On the bottom right, you can see an image of Flappy, the Flappy activity, which is a clone of a classic mobile video game called Flappy Bird. Moreover, there are other activities that let you create complex images, games, animations, and programs such as Scratch, eToys, and Turtle Art activity. So what will I be working upon over these 3 months? So first of all, we will have a look at each of these activities in the further slides. So I will be working upon 3 utilities: Tower of Hanoi, number guessing, Mystic Square, and Scrub Tiles. More of these activities are yet to be decided, which I will decide upon most probably in the upcoming week. And yeah, so first of all, what is 3 utilities? Imagine a scenario where 3 houses, like these 3 houses, are to be connected to 3 vital utilities, which is water, gas, and electricity. Now, you have to lay down supply grid lines over a 2D grid in such a manner that the supply lines do not cross each other. This problem is known as the three utilities puzzle. It is a classic example in graph theory that demonstrates the limitations of planar graphs. It will be a great learning experience for kids. I will be implementing multiple levels for it, where you would have to connect 2 houses to 1 utility, 2 houses to 2 utilities, and so on. After that, we have Tower of Hanoi. So what is Tower of Hanoi? Imagine 3 roads A, B, C, where A is our source node and B or C can be our destination nodes. So these three roads are stacked with a set of colorful discs of varying sizes. The largest disc at the bottom, and the disc decrease in size as you go up. The objective of the game is to move the entire stack of discs from a starting node to a destination node, which can be either B or C. The only 2 rules that are in this game are that you can only move 1 tile at a time, 1 disk at a time, and you can only put a smaller disk on top of a larger disk. So that is a great brain teaser for kids. After that, we have number guessing. This game is played against the computer. The users have to think of a number that lies in the range of 1 to 100. Then the users will be displayed a collection of numbers, and the users need to answer yes or no based on whether the number they thought of exists on the screen or not. So for example, if I think of 56, then a collection of numbers will be shown to me on screen, and I will be asked whether 56 is among the numbers that are presented or not. So after 7 such procedures, the computer will exactly decide, exactly guess what is the number that I thought of. It does so by concepts of bit manipulation, which are beyond the scope of this presentation. But it is a great, kids will love questioning how the computer does it. After that, we have Mystic Square. It is a sliding puzzle. There are 15 tiles numbered from 1 to 15 that are randomly arranged in a 4x4 tile-sized grid. This leaves one space unoccupied in which the neighboring tiles can be slid, leaving an unoccupied space in the original position of the numbered slide. The goal of the user is to make a sequence of moves to arrange the tiles in numeric order from left to right and top to bottom. So that the image that you see on left, see, 1 appears here, but it should appear on the top left position. All we have to do is arrange all these tiles in a numeric order, and you will win the game. After that, we have Scrub Tiles. The Scrub Tiles puzzle is a word tile arrangement game that tests your vocabulary and your ability to think creatively. The user is provided with some tiles on which some words are written. The objective is to place the tiles in such a way that the 2 tiles next to each other have at least 1 letter in common. This does have some similarities to the game of crossword puzzles, and I think it's a really fun game. You can create long chains of tiles which have common letters among adjacent tiles. The arrangement can be either be circular or a straight line. This creates a chain of connected words. And ideally, you should use all the available tiles in your chain. But if you can do so, then the more tiles you add to the chain, the higher your score will get. After that, let's discuss the progress that I have made till now. It's been 2 weeks since I've been selected as a contributor. So the initial development on 3 utilities, Tower of Hanoi, and number guessing activities has been started. I've been working on the following aspects in the previous 2 weeks of the program. First of all, I have implemented generic features such as screen scaling and scene transitions that would be used in all of the activities that I will be creating. After that, I have created art assets for the Tower of Hanoi activity, and I've also added main menu and help instructions to the Tower of Hanoi activity. On the right, you can see screenshots of 2 of my activities. The first one is 3 utilities, and the second one is Tower of Hanoi. In 3 utilities, as you can see, there are 3 houses and 3 vital utilities, and you have to connect all the utilities to houses. There occurs a collision, and you need to figure out how to avoid that. In Tower of Hanoi activity, as previously discussed, you have to move the stack of disks to the destination roads, and you will win. So yeah, that's it from my side, and thank you all for your time.
Awesome. Thank you for sharing that. I know that my son loves all of the games in Sugar, so it's exciting that we will have even more development in this area. I know a lot of kids really like these games. Okay, so we're going to move on to some presentations that were sent to us pre-recorded. So I'm going to share those via their videos. And I think we have enough time to do this.
Hey everyone, my name is Spandan. I also go by Martian, and I will be developing 8 math activities for the Sugar desktop environment under the GSoC 2024 program. So I'll just introduce my project in a brief. So what activities are? These are like, you have applications for Android, right? You have programs for Windows. Similarly, you have these activities which are like executables on the Sugar desktop environment. So I'll be developing 8 math related games and activities for the Sugar desktop environment. The first one which I've worked on, it's the river crossing activity. We all know the popular puzzle where you have a goat, cabbage and a wolf. You are on a ferry, you have to carry them across, you have to come back and all that good stuff. What I'm planning to do is adding more levels with more characters that you can have, like instead of the goat, cabbage and wolf, maybe you can have more people with you have to carry across, and it can get more complicated like that. So that's what I'm working on. The next activity, which also I'm currently working on, is the NIM game. You might have heard about it. It's actually quite famous. You have multiple rows of objects, any object, and you can pick them up. And what happens is the last person to pick up an object basically wins the game. So I'm currently working upon this, and I'm working on implementing the computer AI for this. I'll also be working on Lewis Carroll's game of logic. Oh, this activity is just the bane of my existence. This is so difficult to explain. We will talk in detail about this when I get around to working on it. So for now, let's just talk about the candy game. This is a very simple game. You act like a teacher. There are children around a round table, and whenever you blow a whistle or whenever you click the next step button, in our case, the children will give half of their candies to their right neighbor, and we simply just repeat this process until all children have the same number of candies. This is just a mathematical explanation. This has a very interesting geometric explanation as well. I'll be incorporating all of that theory into the activity as well. Next up, we have the number guessing game. It's pretty simple. We've all heard about it. There'll actually be 2 types of options to play the game. So in option 1, it's just pretty simple. You just have to guess the number, and the computer will tell you if the actual number was higher or lower, and you just have to keep guessing like that. The second option is where the computer guesses your number, and you just have to keep on saying lower, higher, and eventually the computer is supposed to actually guess your number. Next up, we have a slight demonstration of the Pascal's triangle. This is not a game. This is more of, again, just a mathematical visualization and an explanation. We'll get into more detail about this when I'm actually working on this. This is quite complicated to explain on itself. So yeah, this is for later. The three utilities puzzle is quite interesting. You have three houses, you have three types of utilities. For example, here we have water, electricity, and gas, right? So you just have to somehow make it so that no connections overlap, no pipes overlap, but you're still able to provide connections to these three houses for each of these resources. And the basic point is that it's impossible. You can't really do that. In graph theory, we call this a K33 graph, a complete 3,3 bipartite graph. It's actually impossible to do this, and that's what we are trying to explain to children. This is a simple demonstration of graph theory's basic fundamental principles. Next up, we have the Latin squares activity. This one is also quite simple. You actually have a matrix like this. You have operations, and what you have to do is you have to fill in these blanks, right? So that the entire chain of operations in a row and a column result into their corresponding resultants. And when you advance into levels, you'll have more missing spaces, and you'll also have missing operations as well. So, it will just slowly increase in difficulty. It has sort of like a narrative. You start out easy and then it gets more difficult progressively. And next up, we have the illusion box. This one is very interesting. This one I'm really looking forward to working on. This will basically just be a collection of all types of optical illusions. For example, here you have the Judd illusion, right? The point is, like, it looks like it's skewed towards the left, but it's actually on the center, and it's messing with your mind, right? Similarly, the bulging lines illusion. These lines are perfectly straight, but they look like they are, bulging towards you. So in the red lines as well, in the herrings illusion, the red lines are actually not curved at all, but they appear to be curved, right? So this activity will just be a collection of these illusions and explanations about how they work. And overall, I just try to keep it very fun, interactive, and interesting for everyone playing around with it. So that's all I'll be working on this summer. I hope you found that interesting. Thank you for your time.
Great. We have two more presentations. I'm going to reset the stream real quick, but first, before that, in case you're wondering, looking at this and you're wondering what all of this is all part of Sugar Labs. You can go to the Sugar Labs website at www.sugarlabs.org. We are improving the website every day, and very much in the spirit of what we do. We are building it together. So all of the code for the website is on GitHub, and we've had some contributors over the last couple weeks actually help with some significant updates, which is really nice. You can come here, you can learn a little bit more about what we do. And you can, download some of the activities in this section that we were talking about today. There's a section on Raspberry Pi with more information about that. There's a section for Sugarizer with more information about that. Flatpak. So I encourage you to come to the website and check these things out. And Sugar Labs is a registered 501c3 in the US, tax-exempt organization. So if you are able to, please consider donating. You can go to the bottom of the website, click on donate, and we have some information about how you can donate, either by PayPal. You can send us a check. If you're on Facebook, you can also donate that way as well. So on that note, I am going to just briefly reset the stream, and then we're going to go on to our AI projects. So there might be a brief interruption in the stream, but this is a hack so that we can go longer than an hour. Awesome. Okay, so with no further ado, we're going to go on to Kshitij Shah's project, which is Pippy-AI Assistant project. Ooh, come on, copy the link. There we go.
Hello guys, my name is Kshitij Shah and I am going to contribute at Sugar Labs for Google Summer of Code 2024. My project is about adding an AI assistant to the Pippy activity. So Pippy activity is basically a place where kids learn how to code Python. These are the topics on which I'm going to discuss about in this presentation. This would describe my entire project for GSoC 2024 at Sugar Labs. Introduction. My name is Kshitij Shah and I'm currently in second year of computer science engineering at VueJS. My mentors are Ibiam and Walter Bender. Now talking about the project, that is adding an AI assistant to the Pippy activity. It mainly works in 4 steps. 4 stages are there for this project. First stage includes building an AI assistant. AI assistant would basically be generating code for kids and open source developers. These AI models are large language models. Second phase is deploying those large language models on some containerization websites like Docker and Docker Hub. Third would be enhancing the UI of the Pippy activity, where this AI assistant is going to be deployed. And last and one of the most crucial phase of this entire project is integration. In this part, we would be integrating the large language model with the UI of the Pippy-AI assistant. Now talking about the AI assistant, it would be mainly performing 4 tasks. First would be generating Python code for kids along with the examples. Second, it would be helping new developers to the Sugar understand Pygame library and also help them with the GTK basics. Last but not the least, it would also be performing the task of correcting codes of the kids. For implementing this AI assistant, I have tried many models which are open source. Some of them have been listed here. Gemini and Gamma have been developed by Google, and these are quite good and lightweight models. GPT-2 model had been tried by me a long back. However, the accuracy were not appropriate. Hence, I have discarded them from my list. Llama 2 and Llama 3 models, being the sole models of Llama families, have excellently high accuracy, and the code which they are generating are of to good quality and easy for kids to understand. Code Llama. Code Llama is a special model made by Meta. It actually is made for the purpose of generating code for software developers. The accuracy of Code Llama supersedes that of Llama 2 and Llama 3. Mistral and Bloom are some of other models which I have tried. However, their accuracy is not as good as Code Llama. Now, the models which I have tried to shortlisted them as much as possible. Based on the accuracy which they have provided, I have tried shortlisting them into 3. First one is Llama 2. Here we can clearly see I have given the model the task of slicing a string named my_is. The model is able to slice the string and extract all the odd elements from it. I have shortlisted the models mainly based on the accuracy, the resources available, and the open source constraint. There are many models like GPTs, ChatGPT are provided by OpenAI. However, they are not open source. Hence, I've discarded them from this list. Next is CodeLlama. As I said, CodeLlama's accuracy is too good. And here's one of the example. I have asked it to print all prime numbers till 150, and it's able to do so. Besides generating the code, it's also been able to provide me a proper explanation with respect to that. Another example is I asked for I asked is to write me an example of dictionary in Python. CodeLlama is successful in doing that too. It's able to provide me very user-friendly examples which kids can understand. Our third model is Llama 3. Llama 3 is very latest model of the Llama family, and its accuracy is quite high compared to ChatGPT 4. It has passed several good models in testing metrics. Hence, I prefer Llama 3 as well as CodeLlama for our project. Llama 3 model, I have asked him for basic string slicing, and it's able to do it in a very effective manner. Along with the code snippets, it has been able to provide me proper examples. Once any three of the models, once I'm done checking all these models, I would be deploying these models on some containerization websites like Docker or Docker Hub. These are basically the platforms where we can containerize our models. What's the advantage of containerization? Containerization provides very good facility of bundling all the dependencies together. Here you can see how all the dependencies like torch, Skippy, sentence species, transformers, and C transformers have been bundled up. These are bundled up to form a Docker file, and then these Docker file eventually form a Docker image. This is the advantage of containerization. With help of containerization, the scalability and flexibility of the model increases, and hence it can be easily upgraded by another developers. Once our model has been deployed on Docker Hub, we would be enhancing the UI. This is a rough UI of how the Pippy activity would look like after the AI assistant has been added. This is a tentative design and is not sure and can be changed if need arises. This is the final integration of the AI assistant with the Pippy UI. This would be the rough architecture of how the Docker image of our large language model would be integrated with the UI of the Pippy activity. Conclusion. With this, our project would come to an end, and a fully fledged AI assistant would have been integrated with the Pippy activity, helping both the kids and the developers to have a better experience at Sugar. For the future scope, we can try improving the accuracy of a large language model, hence generate better code for kids and developers. With time, better and better models are coming in the market. Once the models have been implemented, we can surely try to implement them as an AI assistant in Sugar. Thank you.
Awesome. So that's Kshitij's presentation on Pippy-AI Assistant. Next, and this is the last presentation of today, and the last of our summer prelude series. We have Qixiang Wang presenting his AI integration in chat activity.
Hello. Hello, everyone. My name is Qixiang Wang, and today I will deliver my GSoC project presentation in Sugar Life. My project is adding an AI chatbot to the chat activity in Sugar. Here's the agenda for today. There's some information about me. Now I'm a senior student majoring in software engineering in Nankai University. And this September, I will go to the UCSD to continue my graduate study in computer science there. I have some experience in chatbots. I'm an AI and web enthusiast. I'm a full-stack software developer and an open source supporter. Here's the overview of my project. This project aims to enhance Sugar Life's chat activity by adding an AI chatbot for kids. This chatbot will engage users in multi-turn conversations, support efficient knowledge retrieval, and guide them through text-based games. I hope that the introduction of chatbot can bring joy for young learners in chat activity. It would be accessible in both private and neighborhood modes in chat activity, which will enrich the user experience for the young users in Sugar. So, what's chat activity? The chat activity allows users to exchange messages with their friends or classmates in Sugar. They can discuss study topics or share personal experiences. To start a chat, users need at least 2 active Excel computers. In a community or a neighborhood, users can create text conversations with other Excel users in this activity. It's a shared activity within neighborhood or connected network. This activity can go publicly or privately. Users can just press enter to send their edited message, just like the chat window on the right part of the slide. For more information about chat activity, please visit this link. And now I'd like to talk about the execution plan for my project. And the first is my chatbot project architecture. The initial architecture of this project consists of 2 main components, the chat manager and the chat engine. The chat manager is responsible for handling the overall management of the chat activities. Its primary functions include input handling and session management. The session management helps maintaining the state of chat sessions, including history and contact. The chat engine is a core component that processes the input and generates responses. For this, I have selected Llama 3, this model, for my project. And here's a more detailed execution plan for my project. I divide the plan into 2 parts. One is AI part and another is Sugar part. In AI part, these tasks include the selection of open source models and data size, fine-tuning of models, implementation of proper engineering methods, and the application of IEG techniques. I think this work can help make and improve the performance of the chatbot of the model behind the system. And another part is Sugar part. This part includes integration of the chatbot and the session management module development. So, This is my plan for my project, and maybe I will adjust it according to my schedule or other kind of things. Hopefully, I think I can complete it in a good efficiency and make them a good result, I think. So, here's my presentation today. Thanks for your listening, and please feel free to reach out to me in Matrix channel. Thanks.
Great. So we have now heard over the course of these two events from 14 students. These are all participating in either Google Summer of Code or Code for GovTech. They have a different kind of gradient in terms of, how many hours they're expected, but I just did some rough calculation. If they're doing on average about 300 hours, that's 4,200 hours of work this summer. So this is quite incredible. We have Walter Bender here, who's a mentor. He's also co-founder of Sugar Labs and on the board. And I asked him if he could say a couple things to just conclude this part of the series.
Yeah, thank you, Devin. Super excited about all this work that people are embarking on this summer. Sugar started off as a desktop for the One Laptop Per Child project, but I think, as you can see from the breadth of these projects, we're really expanding and touching learning and learners across many, many different dimensions, different environments. The work on Flatpak will touch anyone who's got access to Linux. The work from Sugarizer, and anybody who's got a web browser will have access to Sugar. The Raspberry Pi work is to bring Sugar into a synergy with the maker community, and there's just lots of great opportunity there for continued development. Integrating Sugar with some of the modern trends in AI, I think, is going to make Sugar be more relevant on the one hand, and on the other hand, I think we've got some insight into how AI actually can have a positive impact on learning that I think will be an example to the world. And just the idea of continuing to develop ways to engage children in constructing knowledge is what it's all about. I think a lot of the games that are being proposed are going to be engaging in that regard. So it's a great collection of ideas, solid students, and I think that we're going to make a lot of impact this summer. Thank you, everyone.
Great. Yeah, I want to take one moment just to say thank you again to all of the students who took their time out to create these presentations so that, we can all see what they've been working on, what they're going to be working on this summer. So yeah, one last time, round of applause for our students. Okay, have a great day. End stream.